Hey, Algebra 2. Here is the first half of 7.4. We're going to split 7.4 up into two sections just because it's kind of long and difficult. So I wanted to give us some time on this section as opposed to just kind of doing it in one day. It's called Evaluate Logarithms. Okay, this is definitely very new. Okay, so we're going to kind of go through it together. Define the logarithm by relating back to exponentials is our first objective. And then our next one is to evaluate several logarithms. Okay, and we're going to do this by hand and using our calculator. Okay, so before we can talk about logarithms, let's kind of take a little blast from the past. Okay, you're used to me asking you things like, okay, what is 2 to the third power? Okay, what is that? What is the answer to that? What about what is, I don't know, 36 to the 1/2? Okay, recently with chapter 6, when we do our fractional exponents, what is that equal to? And hopefully by now you can kind of answer most of those kinds of questions, right? Like 2 to the third is 8, and even if you don't know it, you can figure it out, right? You can do 2 times 2 times 2. 36 to the 1/2, we know that's 36 square rooted, so we know that that is 6, right? And so you are kind of familiar with that. That's all kind of familiar territory. The focus of 7.4 is for me to ask you a different type of question, okay? Instead of asking you this number to this number is equal to what, I'm gonna kind of switch it up here. All right, what if I asked you 3 to what power is equal to 9? Okay, and actually I'm gonna do it, I'm gonna give myself some more space because I need a little bit more. 3 to what power equals 9? Okay. What if I asked you 2 to what power is equal to 32? And then maybe one more. What if I asked you, let's see, 5 to what power is equal to 1 over 25? Okay. So, kind of quickly think to yourself so you can figure out what these values are. Maybe you can pause the video right now and then unpause when you figured out what these question marks are. Okay, hopefully you kind of have an idea. For this one, our question mark is 2, right? 3 to the second power is 9. Here it's 5. 2 to the fifth power is 32. This one's a little bit trickier, right? We know we took a reciprocal, so we know it's going to be a negative exponent, okay? And 5 to the second power is 25. So this has to be -2 in order for me to get 1 over 25. Okay, well, what you just did is you kind of, by finding these little question marks, by figuring out what these exponents are, that makes these sentences true. This little symbol right here means equivalent to, like this is the same as. You pretty much just figured out what the log base 3 of 9 is, what the log base 2 of 32 is, and what the log base 5 of 1 over 25 is. You figured out all of these, okay? You told me this was 2, you told me this was 5, and you told me this was -2, okay? And so kind of the point of me doing this is to show you logarithms at the heart are really not that bad. We're not doing super complicated math with this stuff, right? We're just kind of going backwards a little bit. We're changing our line of thinking, okay? So what's the gist here? What's the takeaway? Well, kind of think about what we did. Instead of finding the output of these exponential expressions, I found the input, okay? What value do I put in the exponent to make 3 become 9, okay? In other words, I found the inverse, okay? That's pretty much the definition of a logarithm, okay? This is how we pronounce this word, logarithm, is the inverse of exponential. Okay, just like addition and subtraction are inverses of each other, multiplication and division are inverses of each other, logarithm and exponential are inverses of each other. Okay, they're inverse functions, inverse operations. Okay, and so because of that, here's how I can go back and forth between them. If I have a statement in exponential, b to the x power is equal to y, okay, some base to the power of x is equal to y. Then I can rewrite that. Okay, remember this means equivalent to, this is the same as. I can write that as log base b. Okay, the base goes down here, like right underneath as like a subscript. Log base b of y. The logarithm is a function. This is not log times y. You have no idea how many times I hear that. And I want you to hear it from me right now. It is not log times y. If you say that, I will cry. Okay, and I don't want you to, you don't want to see a grown man cry, so don't do it. It's not log times y, it's log base b of y. Okay, think of like when we have this right here. We don't say f times 2, we say f of 2. Okay, it's a function. Is equal to x. Okay, and that makes sense if you think about these statements up here, right? If I look at this first one, this says 3 squared is equal to 9. So that's in this setup right here. This 3 is my b, this 2 is my x, and this 9 is my y. So if I want to rewrite it as a log, that's going to be log base 3, because that's my base b, of y, so of 9, is equal to x, 2. Okay. Another way to think about it is like this little circular trick, right? If I look at b to the x equals y, the way I can rewrite it is log base b of y is equal to x. Okay, kind of like a little circular trick. I can also do it backwards. If I'm starting with the logarithm, b to the power of x is equal to y. Okay, it's kind of like this circular motion. As long as the exponential and the log are on the left-hand side. If you have it switched around, it doesn't really make as much sense. You'll have to do like a backward spiral. But it's kind of like a visual trick if that helps you a little bit. Okay, so let's practice that a little bit, okay? This is kind of new information to us. Let's practice it, all right? Fill in the blanks below involving exponential and logarithmic forms. Here, all we're doing is rewriting. Kind of like on your last checkpoint where I asked you to rewrite from radical form to rational exponent form. Kind of the same idea, right? We're not simplifying or anything extra like that. We're just rewriting. Okay, so I'm going to go from exponent to log or log to exponent. Let's start with the first one. 2 to the third power is equal to 8. Okay, that's circle trick. Log base 2 of 8 is equal to 3. Log base 2 of 8 is equal to 3. Okay, not too bad, right? Not too terrible. Okay, part B, I'm going from log to exponent. 5 to the fifth power is equal to 3,125. And that is true. 5 to the fifth power is equal to 3,125. Okay. Now I'm putting these equations down as like, you should know this, but you should always confirm, right? Yeah, 2 to the third power is 8. I don't know if this logarithm statement is true, but now I do because 5 to the fifth power, if you check that in your calculator, that is definitely 3,125. Okay. Next one, part C. 64 log base 64 of 4 is equal to 1/3. Log base 64 of 4 is equal to 1/3. And then the last one, we'll do this in green. 3, I'm going from log to exponent. 3 to the -4 is equal to 1/81. 3 to the -4 is equal to 1/81. Okay. And so that's kind of I hope you kind of find that trick a little helpful, right? It's a nice little visual that helps us kind of remember how to go back and forth between each one, right? And you can truly see that they're inverses, right? The input over here in my exponential form, okay, I'll write input output. My input here was 3, my output was 8. Remember, with inverses, we switch the inputs and the outputs, the domain and range. Over here, my input is 8, and my output is 3. Over here, I put 3 inside the exponent, and I spit out 8 as my answer. Here, I put 8 into the logarithm, and I spit out 3 as my answer. Okay, you kind of see how this inverse relationship works. And the base of the exponential is the base of the logarithm, okay? The base of the exponential is the base of the logarithm. The base of the exponential, base of the logarithm. Yes, I'm going to repeat it 2 more times. The base of the exponential is the base of the logarithm. Last one, base of the exponential is the base of the logarithm. Okay? Hopefully this is so far sounding okay. We're still going to keep practicing. If it doesn't, if you're just like, I don't know what's going on, Mr. G, totally okay. First time you're learning it. This historically, even for college students, when I taught this in pre-calculus in the college, this was not easy for even college students, okay? So if you're sitting here like, oh, this is like, I don't get this, that's okay. We're going to get there, all right? One extra thing to mention are 2 things called the common and the natural logarithm. Sometimes you're going to see log of a number, okay, and there's no base included. And then sometimes you're going to see, I'll do it in a different color, ln of a number. Also no base, but it's ln, okay? And so these 2, that's intentional, that's not a mistake. What these are 2 special logarithms, okay? Whenever I don't see a base and it's log, this is called the common logarithm or common log. And it means it's base 10. When we don't see a base like this, it's base 10. So log of some number is the same thing as log base 10 of that number. We just don't write the 10 because log base 10 is actually kind of one of the most important bases in logarithm world. It occurs more naturally in the world around us. And so we just kind of, we bookmark it by just like not putting a 10 at all. It gets its own special baseless log, okay? Now for the ln, this one is base e. You remember e from section 7.2, that number e? Whenever I see natural log of a number, what that means is that it's log base e of that number, okay? And it's called the natural log, okay? Remember, e, another name for that was the natural base. And so now you see why it's called the natural log, because it's base e, which is our natural base, okay? So just a few things to keep in mind. And the other cool things about these 2 logs is that those are the only 2 we can do in a typical calculator. You'll have lots of other calculators that can actually do other bases, but typically like on scientific calculators, on most ones that are circulating around, these are the only 2 we can calculate, okay? All right, now that we got that out of the way, let's evaluate some more logs without a calculator. Here, instead of just rewriting because we don't see the answer, we're gonna need to actually find the answer. Okay, so let's give that a shot. Let's start with this first one. Okay, log base 4 of 64. I want you guys to actually practice saying this out loud so you know how to kind of enunciate these things. Okay, log base 4 of 64 is what? Whenever we have something like this that I'm asking you to do it without a calculator, let's rewrite it as an exponential to help us out a little bit, right? 4 to this mystery power is equal to 64. Okay, 4 to what power is 64? Okay, do you know? Can you figure that out? Pause the video if you need to. What is 4 to what power is 64? Hopefully you're saying 3. Okay, so log base 4 of 64 is equal to 3 because 4 to the 3rd power is 64, right? And I can do my little circle trick here. Log base 4 of 64 is 3. Okay, yeah, that's the answer. All right, and so when in doubt, let's write it out as an exponential. Let's try that again with the next one. Log base 5 of 0.2. That looks a little tricky. Okay, if we rewrite it as an exponential, 5 to what power is 0.2? 5 to what power is 0.2? Well, let's write 0.2 in a way that we kind of recognize. Okay, 0.2, do we know what that is in fraction form? Yeah, that is 2 over 10, but 2 over 10 simplifies to 1 over 5. So 5 to what power gives me 1 over 5? Pause the video, or maybe you already know, it's -1. Okay, so log base 5 of 0.2 is equal to -1 because 5 to the -1 power is 1/5, which is 0.2. Okay, and so we have that little circle trick again. 5 log base 5 of 0.2 is equal to -1. Okay, last one, last example for right now. Okay, 1/5 to what power is equal to 125, right? That's what we get from our little circle trick. 1/5 to what power is equal to 125. Okay, well, we know we're going to need a negative in here somewhere, right? Because I'm going from fraction to whole number, from this to reciprocal form. So I need a negative. 5 to what power gives me 125? That's 3. So this is -3. Okay, so log base 1/5 of 125 is equal to -3 because 1/5 to the -3rd power is 125. Okay, I'm writing these little justification sentences to help you kind of continue to make the connection between what we already know how to do, aka exponentials, to this new thing that we're learning. Okay, that way it's not such a huge jump to this new stuff. All right. And now the last set of examples for this section, let's evaluate some of these with a calculator, okay? Round your answers to 3 decimal places. Let's first talk a little bit why is it that we're using a calculator here? Like, why can't we just do it by hand? Aside from it's easier. Notice this first one, it's log 8. That's log base 10, right? Since we don't see a base there, is equal to what? If I do my little circle trick, 10 to what power is 8? Okay, can you figure that out off the top of your head? Probably not, because I can't either, right? So this one, we can't solve it by just kind of thinking or multiplying some numbers together. And so that is kind of why we need a calculator here. So we're just gonna put this into our calculator. You should have a log button in your calculator that you're using or on your phone. Also on Desmos. Okay, let me show you really quick how to do it on Desmos. Okay, just to give you a quick little tour of that. Gonna share my screen. All right, here, if you have your keyboard attached to your iPad, you can just type log, and it'll recognize it as the log function. What you could also do is go to functions, miscellaneous, log right there. And then you're just gonna put 8 inside of there. And there's our answer, 0.903. Okay, so the answer to this logarithm is 0.903. Okay, and so that's our answer. And so what did we just find? We found that 10 to the 0.903 power is 8. Okay, approximately, right? Cool. So that's kind of a way to figure out logarithms that are a little bit nastier. Okay, and now we can do the other two. We can do natural log and then log of 24. And so if you look back in Desmos, the natural log is also in that section of functions. You know, go to functions, miscellaneous, ln is right there. Okay, and it's asking for ln natural log of 0.3, 0.3. Oopsie. There we go, 0.3. It was freaking out on me for a second. Okay, so it's negative 1.204. That 9 will push this 3 up to a 4. Negative 1.204. Okay, so this one. Okay, so here, what is this really asking in the behind the scenes? This is asking e to what power is 0.3. And in this case, that happens to be about negative 1.204. So e to the negative 1.204 is approximately 0.3. Last one, log of 24. Go ahead and try that on your own in Desmos. Okay, or on your own calculator, what you should be getting for that one is 1.380. Okay, so this one is approximately 1.380. And so that means that 10 to that power, 1.380, is approximately 24. Okay, that's what that means right there. All right, so cool. Here's our first encounter with logarithms this year, you guys. Hopefully so far you got, somewhat of a basic understanding. We're gonna practice this a lot in our 7.4a practice. And we'll see a little bit more of it in 7.4b, where we talk about the domain a little bit and its connection to the exponential function, okay? All right, I will see you in that video, okay? Have a good rest of your day.